Come on, my dears, we proceed further in chapter number 2. Let us see now question number 26 about dielectric capacitor. My dears, so far the capacitor which we have discussed, it was parallel plate capacitor, correct? And if the medium between the two plates is not specified, then by default you may take air medium, and if no medium is there, you may take vacuum, correct? So normally we call it parallel plate air or vacuum capacitor, correct? What was its capacitance? Earlier that formula we had derived, C equals to epsilon 0 A upon D, correct? Fine. Now what do you mean by dielectric capacitor? A capacitor in which some dielectric medium is introduced between the plates is called a dielectric capacitor, correct? You must have remembered what is called dielectric medium. A medium which is non-conducting from electrical conduction point of view is called dielectric medium. In short, it is an insulating medium, okay? Poor conductor of electricity, correct? Fine. A capacitor in which there is some dielectric medium in the region between the plates is called dielectric capacitor. Then you may have another question, that why we introduce this dielectric medium between the plates? Just to increase its capacitance. And then ultimately how much does it become? Let us see. Look, the capacitance of dielectric capacitor, I just show it by symbol C dash. You may write it this way, epsilon A upon D, epsilon A upon D. Earlier we were writing for vacuum capacitor, come on, epsilon 0 A upon D, correct? Instead of epsilon 0, instead of permittivity of vacuum, now you should replace that permittivity by permittivity of dielectric medium shown by symbol epsilon, correct? Capital A is the area of one plate and small d is the perpendicular separation between two parallel plates, got it? I repeat, epsilon is here permittivity of given dielectric medium, okay? Now recall the formula for dielectric constant. What was that formula? Dielectric constant capital K equals to epsilon upon epsilon 0, epsilon upon epsilon 0. Then what will be epsilon? K into epsilon 0, K into epsilon 0. Epsilon will be K into epsilon 0, correct? Into A upon D as it is. Now tell me K as it is, but don't you know formula for capacitance of parallel plate air or vacuum capacitor? What was that? C equals to epsilon 0 A upon D. Now speak reverse. If it is epsilon 0 A upon D, you can replace it by capital C, correct? Now tell me, what does this formula indicate? Capacitance of dielectric capacitor is K times capacitance of parallel plate air or vacuum capacitor, correct? With the same dimensions, got it? Fine. But here K is dielectric constant of given dielectric medium, which is always greater than 1. If K is greater than 1, then naturally C dash will be greater than C, C dash is greater than C, okay? So capacitance of dielectric capacitor is greater than capacitance of parallel plate air or vacuum capacitor with the same dimensions, okay? Fine. Before we go for question number 27, which is based upon the graph generator, I would like to explain you one short note regarding coronal discharge. Let us see that explanation extra because it is not narrated in the same article in the textbook and it is not explained in detail. I would like to explain in detail about coronal discharge. Look here. What do you mean by coronal discharge? I am showing you. To understand about coronal discharge, you please consider triangular metallic plate. Say this one. This is triangular metallic plate. This end is very sharp, it is quite pointed, okay? Now we connect this plate with high tension battery. High tension battery is that which has very high terminal voltage as high as 10,000 volt, Okay. Positive terminal of the battery is connected with the plate and negative terminal is grounded. Okay, fine. Now, when you do this arrangement, then what happens? The free electrons in this metallic plate are rushing towards this very high positive potential terminal, and then through the battery they simply enter into the ground. Okay. So, in this process electrons are lost by this plate this way. If the flow of electrons continue this way, then gradually this plate is losing electrons, meaning thereby it loses negative charge, and so it would become more and more positive. And that is why I am showing the presence of positive charges on the surface of this plate. How long that positive charge will go on increasing on the surface till the potential on the surface of this metallic plate becomes nearly equal to this 10,000 volt. Okay, fine. Then after this process stops. Okay, but at that time you have very high positive potential on the surface of the metallic plate, and then because of presence of positive charge you have in the surrounding region very strong electric field, and so far intensity of that electric field is concerned, it is found to be maximum at this pointed end. What is maximum at the pointed end? Because you know formula for surface charge density, it is charge upon area. At this pointed end the area is very small and the charge contained in that very small unit area is found to be maximum. That is why the surface charge density here is maximum. That is why intensity of electric field is maximum at this pointed end. Okay. Now, because of presence of very strong electric field surrounding to this metallic plate, it so happens that the electrons in the surrounding air medium are attracted towards this end. Okay. And when electrons are exerted upon by tremendous very strong electric attractive force, they are accelerated towards this positive end, correct? And when they are accelerated, they acquire very high kinetic energy, and if that kinetic energy is more than the ionization energy for a colliding molecule or colliding atom, then they will get ionized. So, what I mean to say, during the collision of electron with neutral atom, if energy imparted is more than ionization energy, then that particular atom will get ionized. It will be divided into electron and rest of the part of atom, which is now positive ion, correct? This process is called ionization, correct? But then the electrons which are freed, they will be accelerated towards this positive end, and these positive ions will be strongly repelled by positive charge on the surface of metallic plate. So, in this process it so happens there is a flow of all these positive ions away from the plate, correct? So, these all positive ions they flow, their stream is produced, okay? Their flow is now taking place in a direction away from this plate. Now, such a flow, such a stream of positive ions is known as electric wind, okay? And if you want to have some proof, indirect proof of existence of such electric wind, we may just enlighten some candle over here. Before you go for this arrangement, this flame of this candle, it burns and it remains almost vertical, correct? Vertical is straight like this. But then because of the pressure exerted by this electric wind, now that flame is compelled to bend in this direction toward the right hand side in this case, correct, this way. So, there is a deflection of this flame, and when you observe the deflection, it is due to the pressure exerted by this electric wind. Okay. Now, come back to this point. The electrons which are coming here, they will associate with the positive charge here and will make them neutralize. Okay. So, this is how this metallic plate loses positive charge at this corner. That process of losing charge at the corner itself is known as coronal discharge. Process of losing the charge is called discharge, but that discharge process is taking place at the corner. That is why we call it coronal discharge, correct? and electrons through this metallic plate ultimately they enter into the ground. So, because of presence of this battery, constant positive potential nearly equal to 10,000 volt is maintained on this metallic plate. Okay. So, this process will continue. What I mean to say, in this process, at this corner the discharge is taking place, and hence we get the wind of positive ions. Okay. And such positive ions which are spread in this direction, that is away from the plate, are going to be utilized in the working of this instrument, which we will discuss now. It is about the Graaff generator. Okay. I hope you have understood this process called coronal discharge. Got it? Now we begin with this short note about the Graaff generator in this question number 27. Okay. Let me introduce about this device. Here is that device using which we can have very high potential, as high as 6 to 8 million volt, 6 to 8 million volt. Look here, 6 to 8 million volt. 1 million means 10 lakh. So, 6 into 10 lakh, that is 60 lakh. 8 into 10 lakh, that is 80 lakh. From 60 lakh volt to 80 lakh volt, such a very high electric potential we can have using this device. Okay. And then after achieving this very high potential, we just supply very high amount of kinetic energy to some tiny positively charged particles, say proton, deuteron, alpha particles, like that. Okay. And they can be given very high kinetic energy as high as 20 million electron volt. Okay. So, this is the introduction of this device. Just for your kind knowledge, this device was constructed by Mr. Van de Graaff, US scientist, American scientist. Mr. Van de Graaff had constructed this device in the year 1931. Okay, fine. Now, let us see the principle of working of this device. What is the principle? Let us see now principle. Okay. Consider two concentric spherical conducting objects. One of them is small sphere having radius small r, having charge small q over its surface. Another conducting spherical object is in the form of big spherical shell having radius capital R and having charge capital Q. Okay. Both these spherical conductors are concentric. Their common center is here. Got it? Fine. Now, just select one point on the surface of this small sphere and one point on the surface of big spherical shell. Okay. And let us find out total electric potential at each of these 2 points. Come on, at point A, let the potential be shown by symbol V small r, because it is selected on the surface of that sphere which has radius small r. Okay. Tell me, how many potential values you will get at this point? Depending upon number of charges, because you have 2 charges, small q and capital Q. Because you have 2 charges, you will get 2 values of electric potential. Come on, take it one by one. Where do you find this point A? On the surface of this small sphere. And on the surface, what is the electric potential? K into charge upon radius, K into charge upon radius, K into charge is small q, upon radius is small r. Correct? Plus, at the same point, how much potential will you get because of this charge? Don't you find this point inside this spherical cell? Yes, this point is inside this spherical cell. And for a point lying inside the charged spherical cell, don't you know the potential formula? It is the same as electric potential on the surface. And what is electric potential on the surface? It is K into charge upon radius, K into charge upon radius, K into charge on big spherical shell is capital Q, upon radius of big spherical shell is capital R. K into charge upon radius. Correct? Fine. Now let us find out total electric potential at this point B. Okay, shown by symbol V capital R. V capital R, because it is on the surface of that spherical shell which has radius capital R. Come on, where do you find this point? Outside the charged sphere, outside the charged sphere, correct? For a point outside the charged sphere, what is the potential? K into charge upon distance, K into charge upon distance, K into this charge is small q divided by distance of this point from this common center, and it is capital R, correct? Plus potential at the same point due to this big spherical shell. This point is on the surface of this charged spherical shell. For a point on the surface of charged spherical shell, what is the potential? K into charge upon radius, K into charge upon radius, K into charge is capital Q, and radius of big spherical shell is capital R, correct? Fine. This is the total potential on the surface of inside charged sphere, and this is the total potential on the surface of outer charged spherical shell. Okay, fine. Now let us find out potential difference between points A and B. Between points A and B. So I am writing here potential difference between, that is PD. PD means potential difference between points A and B. It will be this minus this. Come on, this minus this means this minus this, correct? But when you take this minus this and this will cancel. Now it is this minus this, in which k into small q can be taken common inside the bracket, 1 upon small r minus 1 upon capital R. Come on, k into small q taken common inside the bracket, 1 upon small r minus 1 upon capital R, correct? Now look at the signs of all these terms. K value is always positive, small q is the charge on this inside sphere which is positive, q is positive, small r is less than capital R, small r is less than capital R, this small r is less than this capital R, and because this term is smaller, 1 upon smaller term will give you bigger value, minus 1 upon bigger term will give you smaller value. So bigger minus smaller, that bracketed term will be positive. This is positive, this bracketed term is also positive. Multiplication of 3 positive numbers will give you positive value, correct? And when the difference is positive, this difference is positive, what does it mean? That this will be greater than this, correct? Come on, V small r will be greater than V capital R. V small r will be greater than V capital R. Okay, fine. What does this mean? Potential on the surface of smaller sphere is greater than potential on the surface of bigger spherical shell. Here potential is higher, correct? Come on. Here potential is higher and here potential is lower. Suppose here potential is, I am taking for example say 200 volts suppose, and here potential which is higher than 200, I am taking say 500 volt. Okay. Now tell me, if you connect these two conducting objects by some conducting wire, say metallic wire, then you know electrons have a tendency to move from point of lower potential to a point of higher potential. Here potential is low, here potential is high, so electrons will move this way, correct? Through that conducting wire, they will move this way. And if electrons are moving this way, tell me in that process, come on, the outer spherical shell is going to lose the electrons, so it will lose negative charge, and so it will become more and more positive. So you will have accumulation of more and more positive charge on the surface of this outer spherical shell, and then the electrons coming here will neutralize this positive charge, correct? So at that time we require to supply constantly some positive charge on the surface of inside sphere. If we can make that arrangement, then constantly it will so happen that electrons will continue to move from outer shell to inner sphere, and in that process there will be accumulation of more and more positive charge on the surface of very big spherical shell, and that is how we can have very huge quantity of electric charge on the surface of very big spherical shell, and that too at very high potential. Okay, fine. So, this is how we can raise the potential on the surface of outer spherical shell up to 6 to 8 million volt. Okay? And then after we are going to make use of that high potential, how I am showing you. Let us see now construction. How is this device constructed? I am showing you. Here is a diagram which gives you idea about the construction of this device. At certain height from ground, we just install, we just mount very heavy, very strong steel chamber. This is steel chamber. It is very strong, very big. Okay? Inside this steel chamber, we just install very big metallic spherical shell. We just mount it on the two non-conducting strong pillars. These two are the pillars which are non-conducting, which are very strong, on which this very big metallic spherical shell is mounted. Okay, fine. Here we have two pulleys, P1 and P2. P1 and P2. Surrounding to which we have kept one non-conducting rubber belt, which is called conveyor belt. Conveyor belt. It is kept in contact with the surface of these two pulleys, and it is passed over these two pulleys this way. Correct? We just want to keep this rubber belt moving this way, going up from this part, coming down from this part. But for that we need to have some rotational motion in these two pulleys, and for that we just connect this pulley with electric motor. When you switch on that motor rotates this pulley this way, and hence ultimately the conveyor rubber belt is moving this way. Correct? Fine. Then here we have two metallic brushes, C1 and C2, having such pointed teeth. These are the teeth of that comb, we call pointed teeth. Okay? Now this comb is called spray comb, because we are going to have spray of positive charges from this comb. We call it spray comb, and here this comb is called collector comb. This is spray comb C1, this is collector comb C2. Okay? Now this spray comb is connected with a high tension battery having terminal voltage, as I explained earlier, very high, 10,000 volt. So you have very high positive potential on the surfaces of these teeth. Correct? And especially at these pointed ends, the intensity of electric field is very high, from which there will be a phenomenon of coronal discharge. Okay? Fine. Now inside this steel chamber we have filled some gas like methane or nitrogen. Okay? And that too at very high pressure, as high as 15 atmosphere. 15 atmosphere. Okay? What is the purpose of keeping very high pressure of this gas? I am showing you. This belt is kept moving with a speed of around 100 km per hour. 100 km per hour. Now let us see working of this device. Okay? Working. Through this spray comb, as I explained earlier, with the help of process called coronal discharge, there is continuous spray of positive ions. That is continuous spray of positive charge, and that positive charge is deposited on the surface of this moving belt. Correct? But because belt is non-conducting, charge itself cannot move on the surface of the belt. But then this belt is not at rest, belt is continuously moving. So what this belt will do, it will take that bunch of positive charges, that collection of positive charges, up with it this way, in this direction. Okay? Fine. So whichever positive charges are spread are carried by this belt in this direction, that is towards upper pulley this way. Fine. But when they come here, you know, compared to the potential on this surface, potential on this inside sphere is very high, right? And then when you have connected these two with the help of this metallic brush, it will so happen that electrons from this outer bigger spherical shell will move towards these points of high potential, correct? Here potential is higher, so electrons will move this way. And if electrons will move this way, then they will come here and they will associate with these positive charges and will make them neutralize, correct? That's why I am not showing here any charge. For this part of the belt which is on the right hand side does not carry any charge. That's why I am showing here the belt which is chargeless. Okay, fine. Now, because electrons have moved from here to here, in the process this shell is continuously losing the electrons. Losing the electrons means losing negative charge. Losing negative charge means acquiring more and more positive charge. That's why there is accumulation of more and more positive charge on the surface of the outer spherical shell. Okay. Now, question arises, how long this accumulation will continue, correct? Listen, it so happens when there is accumulation of positive charges more than a certain limit, these positive charges, they start repelling each other mutually, and then they are likely to lose the contact with the surface. They go out of the surface. That process is called leakage of charge, correct? If we want to prevent that leakage, or if we want to decrease the rate of leakage, then we need to exert some pressure on those charges so that they will be compelled to stay on the surface of spherical shell, correct? And for that purpose only, we are filling here some gas like methane or nitrogen with very high pressure, as high as I told you, 15 atmosphere, correct? And because of the pressure exerted, these charges are more or less compelled to remain on the surface, correct? But then also there is leakage which is taking place, no doubt. The rate of leakage is decreased. Now, it so happens after some time that when you are depositing here more and more charge because of this process of coronal discharge and this collector belt, collector comb, it so happens that here on one side the positive charge goes on increasing, on other side positive charge is going on decreasing because of leakage. After some time, the rate of arrival of positive charge and rate of departure of positive charge, they become equal. That is, rate of depositing positive charge and rate of removal of positive charge, they become equal, correct? At that stage and then after, we cannot increase any more amount of positive charge on this spherical shell, correct? So, that gives you upper limit of the quantity of positive charge which you can accumulate, on the surface of the spherical shell, correct? And at that limit, at that upper limit, what is the potential which you are having on the surface of the cell? It is as high as 6 to 8 million volt, correct? Then you may have a question in your mind, that same potential we could have here also, correct? Yes, that is true, but the surface area of smaller sphere is very small, so you will have very small quantity of positive charge, correct? And here what happens, because this spherical shell is very large, you will have very large quantity of charge, and that too at very high potential, correct? So, this is a device with the help of which not only we can have very high electric potential, at the same high electric potential we can have very huge quantity of electric charge. Okay. My dears, just to visualize this working very nicely and effectively with taking lot of pain and labor, I have prepared one animated video clipping for showing you the working of this device. Okay. I hope you will appreciate after watching it, you will really enjoy. In that video clipping, I have shown here one electric motor which runs this pulley and this belt. Here I have shown this metallic brush constantly spraying the positive ions, and constantly the charge on the surface of the spherical shell goes on increasing. That whole process is synchronized nicely, and that will be displayed to you in this video. Okay. Kindly enjoy it and then just give me your opinion later on. Okay. Just enjoy it for 4 or 5 minutes, please. My dears, tell me very frankly, have you enjoyed watching the video clipping which displays the working of this Van de Graaff generator? Have you enjoyed? Thank you. My dears, if you don't mind, I would like to give you very small piece of advice. First of all, tell me, how could Mr. Van de Graaff construct this device? How? He must have taken very great amount of interest, then only he could do it. Correct? That is sure? Fine. That interest led him to become a scientist. But tell me, when at one stage he was a student like you, did he know that he is going to become a great scientist, and so that he will just construct one such a device which will be helpful to the human being and it will be remembered for all the time to come, and his name will be there in the history for permanent time, and I mean permanently. Did he know at that time? No, he was a student like you. But then, because he took interest in physics, that interest just led him to this success. So, my dears, it is the interest which one must take, which one must cultivate, and then only he can progress. So, I just urge everybody to take enough interest in whichever subject you are interested. Just don't get satisfied with that degree of interest. Go on increasing continuously. Correct? Then at one stage you also will become scientist in future. Correct? God knows. Correct? Neither you know nor I know. Correct? But at this juncture I just remind you to take interest, please. Like everybody in the childhood, they like to play cricket. Same way, like other small children, Sachin Tendulkar also took bat in the hand at the age of 4 years. Now tell me, at the age of 4 years, did he know that he will just earn this much name and fame in the entire world? He never knew that. But then it was his interest, his, you can say, very great hard work for the game of cricket that led him to this success and name. Correct? So please don't get satisfied with your progress, because progress should not have any full stop. It should have at all the stages in the life, progress should have only a comma. Please. Now, my dears, let us see some extra note. What is that? We have studied one very important electrical component called capacitor in this chapter. Correct? Now, let us see some of the very useful applications of capacitor in our day-to-day life. I am showing you. I have written here, where is capacitor being used? It is used in the circuits of radio and TV. After 12th standard, if you happen to study further in the branch called Electronics and Communication Engineering, there you will study the working of capacitor in the circuits of radio and TV. Okay? Then, for giving electric shock to the patient in medical treatment. If a person is having heart attack and suppose his heart goes down, I mean the beating goes down, at that time, just to restart that heart which has been down, the doctors use one equipment, and that medical equipment is known as defibrillator. Defibrillator. Using that defibrillator, actually what we are doing, we are giving the electric shock to the patient, and in that shock we require to have some jerk. Correct? Some electric shock is given. At that time we require to just pass some electrical pulse through the body of that patient, and then we require surge of electric current, and that electric current for a moment is to be flown with high amount, and that current we obtain through the discharging process of a capacitor. So, the capacitor which has been earlier charged is allowed to discharge in this process, and then that electrical shock is being given to the patient, correct. So, there is also application of capacitor in the field of medicine also, in the instrument, in the equipment, as I said, defibrillator. Okay, fine. Then in computer keyboard and in microphone, capacitors are used. Then in electric motor and pulsed laser, how, that you will study in your higher standards. And then last, in the flash gun of camera. See, in any digital camera or even in this mobile phone, when you take photograph in the region of insufficient light, in the region having some darkness, if you happen to take a photograph, you need to make some light properly incident on the object, correct. So, at that time you require very high intensity of light, no doubt for a small time, but you require high intensity of light, correct. That we obtain by discharging of a capacitor. When capacitor is allowed to discharge very urgently, it loses lot of electrostatic potential energy, which is ultimately converted into light energy. Okay. So, that is how capacitors are being employed in the flash gun, and that is the use in the camera, and that too in the mobile phone also, correct.